If you're watching this, this is a follow-up video to the last one that I did specifically on this power supply. Now, I've come across a little bit of hopefully useful information, which is on here, specifically about one of the components on the riser board. And I've also looked into learning about octocouplers. As for having a basic understanding, yes. As for being able to test them, not so much. So, what can we do today? Well, today I figured I'd take a look at the bottom side of this board, where all the circuitry, or some of the circuitry is apparently, and see what I can do. So, and it really sucks that there's no more of that loud crack sound when you take these screws out. It just, I don't know, it was that special thing that I once had. As for the light, I was really hoping it was going to be much more sunnier today, but no. Oops, I left something turned on. There we go. Oh, okay. I was expecting a lot of circuitry underneath here. Must have been a different model. If you look it up online, you'll find a photo that someone submitted where it just shows where the fuses are for the three different regions, the American, the Japanese, and the Australian. And unfortunately, Australia is more complicated than any of the others. So, if I lift this back out again, that means all the complicated circuitry is on this riser board here. Now, when it comes to me actually removing this, I'm going to have to desolder these pins. I'll have to... I should be able to desolder these two studs here which hold the heatsink in place. So the question is, can I measure the resistance of these resistors? Let's find out. So here's the first one. .5 ohms. .387 ohms. So I'm guessing these are going to be 3 adjustment parts. I have to admit, this solder is actually rather soft. So these octocouplers, they are all surface mount. Oh, there are actually a few more other little IC components here. Don't know if you can see them, but no, you wouldn't. So I'll bring this back up again so you can see it. I'll use this for pointing at. So you got this little package, this little package. These are the octocouplers or octo isolators. You got a main IC down there, which if I remember correctly was a 2 op amps. So let's get down to registering what everything is on here. Now, I'm not going to be able to get this working today. That's just a pipe dream. What I have ordered is a component tester, so I'm able to remove these packages here, the little tiny transistor that's hidden away. I can remove these capacitors. They're most likely fine. But I should be able to test relatively everything else. So at this point, it's, yeah. So I know those fuses are all right. Is that refocused? Yep. Let's see what happens if I put my light on. Ooh. That's a lot better. So what do we got on here? KH472M. X 1 Y 2. That could be XIY2. And then it's BS. Yep. BS 415. Now there are 2 of these. Okay, so if I remembered correctly, I traced back the 3 voltages to here. It's a real shame I didn't have an oscilloscope that I could actually test the oscillator on this with to find out whether or not it was, well, the downside is I wouldn't know what frequency it was supposed to step it up to. Oh, hello. Can I remove you? Possibly. Okay. So this board is populated with information. Doesn't tell you the value of resistors, but this apparently should be a 2 amp fuse, which I can see the lettering on here, so that fuse there. I can't see any information on those variable potentiometers. I'm also concerned if I do remove this whole thing, this elastic here might cause some tearing. Okay then. So I figured out where all these prongs were. So pin 1 is ground. Alright, time to go live again. So, in relation to ground, pin 2 is 3.3. So I'm getting a little voltage spike on these. Let's exit. 12 volts. Nope. So they all run off there. All right. Now, there's potentially a charge in here, so still really need to be careful. You know, I got a feeling those all shouldn't be shorted to ground. Did I do that wrong? I don't know. Alright, so those should be ground. These top two should be 3.3. So to be very clear, I can stick that in the center. And 3.3 volts should be pin 3. Okay. Let's try plugging that back in again. Turning it on, setting to voltage. So something that was recommended to me was the octocouplers. Now, not really knowing how to test those, I become really interested in this here. So to figure out which three are positive, negative, and whatever, let's find out what they are. So, continuity. And I'm going to look at the bridge rectifier and state that this pin here is ground. Okay, so ground, ground, not ground. Okay. 11, 12, 13. Now let's find out what you are. So I should be able to set you to DC. I should be able to plug you in and turn you on. And then I should be able to go from you to you. 0.6 volts. You know, I got a feeling that's not right. .6 volts. So how's that coming through on you? Oh no, that's coming through okay. Alright then. Looks like we can actually ignore the riser board and focus on the high voltage side. So the question I have is what could have blown in there? Looks like I just completely took this side off. I mean, those octocouplers are going to need something a little bit more to work. But this is such a pain to be able to look into. You know, I really wish I had a few more of these. I could just tear one completely to pieces, you know, safely remove everything. But unfortunately I don't. So what are those two beads in there that are connected to one another? Hello, you're a Zenny diode. Just a second. So let's remember to unplug you, just so there's no phantom voltage. And what I should have in here is a Zenny diode, or a Zener diode. So I'm guessing that's a forward voltage of 1.9 volts. Which I'm going to have to make sure I note that down, which is ZD101, ZD101, forward voltage of 1.911 volts. Okay, so that's the first test. Now what happens if I swap them? 0.5 volts. So to me, if the octocouplers require, say, a volt, well, that's 1.8. There you go, 1.9. So that Zener diode's doing something. Something I'm finding very interesting. I don't know why. Why do I find that interesting? Okay, so I should be able to test those two probe points on this side and get the same kind of response. Oh, that's close enough. So that Zener diode goes to here, and what's that? A tiny capacitor. Probably not. Let's check the connectivity in that one. Alright, so that's definitely not shorted. Oh, I did not notice a component on this side. Can't really make you out. So to figure you out, I would have to remove the transformer, and that's a fuse actually, I think. Is that F? Yeah, that's a fuse. That's a 2 amp fuse. Alright, so I just found a fuse right here. So that sucker's a fuse. Hello. So this is the part where I really should be drawing out the schematic, and I'm going to try and start doing that, I think. So tracing back, I have this component here, which is Q102. Looks like a tiny little transistor. Now I can tell this is the hot cold side, and this should be an output, which means I should be able to measure what that is. On and U and U. That's not going to work. U and U. So we're getting 0.6 volts. I wonder how further back can I go where I find another component. I really should be writing that down. So this thing. Now, .6 volts there, but this is its input. So what I should be able to do is so that's definitely a ground rail. So it looks like a component on the hot side may have failed, which I couldn't actually track down before. So taking a guess, we need to get 1.9 volts onto this, but it's not. That's not outputting what it should be, I'm guessing. So this should be the input pin, which is then hit with a resistor. But why would it be bent in like that? Which is hidden under this heat sink, and it's R106. Resistors usually aren't bent in like that. They're usually, oh no, these components are all bent in on each other. Okay, so that's a single resistor. That then travels up. So what I should be expecting is a link between here and here. There's a much thicker resistor, a thermistor, which should be these two. It's unplugged. I thought I screwed up then. Okay. So there are 4 more resistors. All right. To really test to see whether or not it's something on this side or this side, if I had a power supply I could program, I could test that out, which unfortunately I don't. Ah, hello. I think I might have found you. I think I can see you now. Okay, so another component to look up is Q102. And the markings on here are D130Z. D10. Nope. D130Z. Ooh, that diode. So where would that diode be? That diode should be here. So let's find out. So, this way? No. This way? Yes. Forward voltage of 0.5 volt, which, if that's a normal diode, that's a normal diode. So that Zenny across here, by rights, where does that Zenny go to? So why would it go all the way back here to create that voltage reference for these 2 pins? You know, the sad thing is I'm completely going to forget all this later, so this video isn't even going to help me. But just take some note of what I've found on here. Alright, so I'm guessing it's not the low side or the output, it's the input. Okay. So if I look at this if I look at this, these two should connect. That doesn't. So number 2 is a resistor. So what is... Ooh, K2700. Ouch. So K2700. I'll look this up, and if I can find out which is the ground pin, I can continue this on. Okay, so I'm back. Now, having looked up online, I came across what these two components were, and this is a ceramic disc capacitor. So we've got two capacitors here, which they're actually labeled as. And I'm pretty sure I've already tested those two. Now, am I unplugged? Yes. All right. So the only voltage reference I can actually see here is this Zenny diode. That's it. I can see a couple of inductors in here. 3. 2 of them are slotted together. I see a rather interesting resistor. So you've got the diode, and then you've got this resistor here. So we've got the diode, which is those 2 pins. We've got a link wire. So it should be these 2 here. Alright, so that's resisting. Well, really at this point, my approach will be, once the tester comes, to remove this heatsink, which hopefully I can do without damaging the board, and then testing that. But for now, can I actually get a voltage off this? So I know that this is going to be ground here. Not ground, ground, not ground. Okay. Oh, it's even labeled on there. GSG. No, the source is labeled. So this is its source. output goes through this fuse. So really, I should be able to poke here and find out what's going on. Okay, let's give that a try. Not a good idea. So you're negative and you're going to be positive. Right. Plug in, turn on, set to DC volts. Zero 0.7. 0.7. 0.6. 0.7. Well, that's interesting. Could it? Maybe it is that board. So I suppose if we track it back even more, so I'm getting 300 volts here, and then it spits over to here. So no, probably not a good idea. All right, turn it off. Unplug. I know the fuse works. I know we've got a MOSFET and a transistor. Either of two could be buggered. So I can't actually short these pins out to find out. No, I'm not going to do that. So if this is the drain, I'm going to take a wild guess here and state that it's possibly the MOSFET or the transistor. I'm going to stick with that. I will have to wait until my component tester comes, when I can desolder these two components, take a few photos to ensure that I don't screw up reassembly, and then find out whether or not it's those that have failed. So if that Zener diode's working fine, that'd be the voltage reference. 1.9 volts. But what about you? What are you? Two diodes. So by rights, no, you're on the cold side. I don't need to worry about you. I need to worry about what's on this side. I think that spark gap's way too big, this one here. I could be wrong. Well, until I can actually pull it out and do a test. I mean, at least I've got the list here about what the stats should be. So if I pull the component pull it out, pop it into a component tester, and it's nowhere near that, then, well, that's potentially the problem. Yeah, this was a fun poke around of the Nintendo 64 Australian power supply. What do we got? NUS 002. I'm going to terminate the video here and post another one once I've got some more stuff. See ya!